All right, so I just kicked off the recording. This is the, I guess, November 1st meeting of the Resource Management Work Group. Got 2 topics on the agenda, but I'm not sure if we actually have their representatives on the call. So if someone that is not recorded here wants to talk about the initial FPGA support proposal that was linked, please speak up. And if not, we'll move on to the device plugin architecture document. Is someone on the call that was able to speak about FPGAs?
I'm pinging Sundar, so he should be joining soon.
Okay.
So maybe just hold off on that for now.
Yeah. So then the second topic, I don't actually know who the lister of this was. I probably should get a template here so that people are required to name themselves as wanting to drive it. But who wanted to talk about the device plugin architecture document again?
I think Renaud added that.
Yeah, looks like we're not added it. Not sure what the exact agenda is.
Renaud, are you there?
It looks like he's rejoining.
Yeah.
This might either be a really quick meeting or a really long meeting, depending on how Zoom goes.
I think
it looks like Sundar joined, so maybe we can jump back to the FPGA proposal.
Yeah.
Okay, Sundar, are you able to take over and drive the discussion around FPGAs?
Sandra, could you hear us?
Hello? Okay, let's see.
Yeah, I can hear him speak.
Start video, okay.
Your voice is really feeble. You might have to get closer to the microphone or adjust something else.
Renaud said he's good to go. So.
So basically, whoever we can hear first has probably got the floor to talk. So Sundar, I heard you saying something like start video, but I'm not sure if that was exactly you. All right, Renaud, can you talk? And then if we can hear you, maybe we can be productive while Sundar figures out what's going on with his mic.
No, we cannot hear you yet, in case you're trying to speak.
Oh, hello? Can you hear me now?
Yes, Sundar, we can hear you.
Okay, very good. Excellent. Okay, thank you. There was some confusion about the exact time. I joined a few minutes earlier and was saying the host has not yet joined, and I was told it's actually 1 hour later because of daylight savings time. So it was a bit of a, sorry about that.
Sorry.
All right, so you ready to kick off the discussion topic you're throwing on the agenda?
Sure. Yep. Okay. Do you want me to get started on the FPGA stuff?
Yep, floor is yours.
Okay, thank you. Okay. Okay. First of all, thanks a lot to Samuel Ortiz and Alexander Kanevsky for helping me in writing this document. I think many of you have already looked at the document, so we can kind of either go at section by section, or if you've got specific questions, we can look at that. I'm fine either way. Would you like me to start by summarizing the overall proposal?
Yeah, so Sundar, I have not had a lot of time to review the documents, so a summary would be appreciated by me.
Okay, good. So the overall background is that FPGAs are a different breed of devices. So compared to other devices, there are additional factors like how you program the device and how you handle images, which are used for programming and such. In addition, when you do the programming, there could be multiple accelerators in the same device. So I could have an FPGA with 2 separate partial reconfiguration regions, and each region may contain a different accelerator. And also, the image needs to match the particular region type it's meant for. So when you actually generate, let's say, an IPsec accelerator, for example, you would synthesize an image for a particular region. You cannot apply to some other region even on the same FPGA. So the software has to take care of all these things. And when you pick an image to do the programming, you need to make sure it's matching the particular region type. There may not be something in the hardware which prevents a bad programming. Some devices may do it and some may not. So we can't count on that. So given all this, there is, I believe there's a need for a different approach, but a lot of that will fall in the category of tracking device resources, which is meant to be taken up later. Programming with images should be best left to the plugin. We need to put enough information for that. And that again can be taken up later. And the third category where we need some changes is in handling security contexts. So what I mean by that is that if a container or a VM were to open a device and try to manipulate it, for example, by doing an mmap to map the PCI registers to its memory address space, that requires some privileges. So there should be some way for the container to express that, or for the plugin to say that this kind of operation requires these privileges. So based on all the discussion we've had in the document over the past couple of days, I think the overall tenor of the feedback is that we should not make any of these changes just yet. We should try to stick to the APIs already proposed and see what limitations will arise out of that. And based on that, and also based on further resource management discussions, we can make further changes.
I think I'll like strongly plus one that that path forward. Mainly because like we can start with something very simple, like saying FPGA nodes are dedicated, and then like people are off to do whatever they want with those nodes to begin with, and we don't like really try to solve multi-tenancy or like security there to start with. And then as we understand the overall life cycle, we can improve the system over time.
Yeah, also my impression is that the current API is can allow us to start with something simple, like to support statically programmed FPGA, and may also support container programming model in certain sense.
Yeah, so that's a good point. In that, like, let's just keep it very simple. I think we can make some safe assumptions that people are not going to reprogram every day or like every hour. And so have like a really simple control logic. So like give people a complete solution that they can use, even if it has some limitations. And then like start prioritizing what limitations needs to be addressed right away, and then bring it back to the community essentially. I'm just worried that like we might end up like adding too many features, looking at it just from an infrastructure perspective, whereas like the actual issues for pain points for users might be somewhere else in the system.
Okay, sure, fair enough. That's fine. Yeah. To answer one of the earlier questions, yes, the main things we want to address are statically programmed devices as well as container program model. But I should also emphasize that the current APIs do not allow for handling local memory in any form. So if you've got two FPGA implementations which differ the amount of local memory, there is no way to express that or to request for a certain amount. So even the local memory has to be outside the API for now.
So the assumption so far is that like devices are not really shared. And if you have to share, then we need like better APIs essentially. Like for example, we share the main memory and like we share CPU, and like that requires some extra inbuilt logic into Kubernetes to make that happen. We don't have a good extensible way for applying such a logic to other resources. So to begin with, if we can just like statically define what the memory sizes would be for different accelerators that you burn into an FPGA, then that might be good enough to start with. Maybe you express that as part of your resource name, for example. Just find the easiest possible way to have users consume this resource.
Mhm.
and then we can come back and like find out how, do we even have to improve it, and if so, like what would be the right user experience.
So let's say I do a POC to show how the current APIs can be used for FPGAs. What kind of feedback would you expect in the future? Should I go to some customers and get their feedback, or is it good enough for developers to play with it and point out the problem areas?
I think, like from my understanding, I think a major problem to support container programmed devices is because the local memory. So we expect a plugin not only managing the computing devices, but also manage some local memory associated with those computing devices. So I think you mentioned in the document that you can start by just having a computing device to have some statically allocated local memory with that model. And so I do see your point of supporting like a dynamically local memory allocation, and this information from my understanding is expected to be a local knowledge or plugin. Is it true?
Initially, it can be completely hidden by the plugin. But what I'm trying to convey is that in general, it may need to be exposed to the resource. So the container may come and say, I want 4 GB of local memory for this IPsec accelerator. But not all devices may actually have 4 GB of local memory. So you'll need to actually pick a device at the scheduler level or the kubelet level, which actually contains that much resource. So to begin with, we can make some simplifying assumption like all devices contain enough resources for any use cases. That would be a kind of a very restrictive assumption, but we can start with that. But in general, we'll have to somehow expose the resources, and the container should be able to ask for that.
Right. So you could, like, one of the things that we state right now is like nodes are homogeneous.
Mm-hmm.
And actually like approach heterogeneous nodes more systematically. So you could like consider adding labels. Like this was part of the original device plugin design as well, that like plugins can expose node labels. So you can assume that on a given node, accelerators foo and bar that you have programmed onto an FPGA would have so much amount of memory, right? Like we can use node labels to do some sort of like cheap scheduling for now.
Okay, sure. Okay.
Yeah, and in terms of like the overall, like your previous question was like, what information do we need in order to consider adding more features? Like personally, I would prefer having real customer feedback rather than like developer feedback, because we are really creative and like we can think of awesome use cases, but at the end of the day, the customer might not be that sophisticated. So I would like to see like overall end-to-end workflows. Like, I mean, probably like network acceleration is one use case. Other use case that I saw in your doc is about like predictions, like ML predictions. So I'd like to like see overall solutions for that, where as an end user, I can walk through a journey or a guide and actually consume this through Kubernetes. And then we can prioritize like how we're going to deal with the different issues that the user would face.
Okay.
So it's a bit of a catch-101 because if with the current API, we basically are very restricted in the with the container programming model. So what you would not allow customers to do with the current API is for them to go and really work on containers that could program FPGAs, which is a use case that's is very important as well.
Yeah,
so yeah, go ahead, sir.
I was just going to say, like, can you do it in a lockstep fashion, and that like you get a node? It's like installing drivers, right? Like you get a node, you program it the way you want it, and then you bring that node online into a cluster because you already programmed it the way you want it, and then you can start having workloads run on that.
But that's basically saying that the operator and the user are the same entity. What we're thinking about is a user coming into the cluster with empty FPGAs and getting a specific region to program whatever IP it needs to program into.
Sure. And can we simplify that scenario by like saying that the user is going to get the whole FPGA, at least in that case? I mean, I'm just not seeing why we have to like tackle all the problems at the same time.
No, I agree with that. I definitely agree that we want to restrict ourselves. But the thing is, by not acknowledging that user need to understand how much memory they can get from how much memory they can request from for a specific IP, or what are the security context that their container is going to need for programming the FPGA, we kind of remove a one very important use case and put it outside of the user reach. So I fully agree with your statement that we should go in steps, but with the current API, we can't even have customers using that, going through that specific use case. So it's hard. Yeah.
So what if like I just want to like think through the thought of like having customers go through the node lifecycle. What if like these nodes were dedicated in the sense that you're not sharing these nodes with other workloads, at which point you can safely like hand over maintenance of that node to the end user. And then like they are free to like reprogram the machine and like use it however they want. And this is actually a very common practice even at Google, where you have like specialized hardware that's used by a small subset of users, then you just have them use it rather than like bending the system to like deal with all those scenarios.
Okay, so it would be basically restricted this specific use case to having a container fully using one FPGA and not sharing the FPGA anymore.
Yeah, so that
which is a, I mean, it's a first, it's a good first start. I'm just trying to understand and make sure I understand what you guys are saying.
Yeah, I guess our question is like it's how important it is to support multiple containers sharing FPGA on a single node.
I understand, and I think it's a fair point. So we could say that the container programming use case would be, we could restrict that to one FPGA per container, or one container per FPGA.
Yeah, I mean, in fact, I'm like going one step further and saying, for the initial version, for maybe for like the next 6 months, what if you just have users like completely own nodes that have FPGAs, and you give them a solution, like you give them a CRD or whatever that simplifies burning FPGAs for them, and you use like Kubernetes APIs to simplify the workflow, but then like those nodes are not being shared, at which point like your security restrictions are reduced, and like you can like use the workflow that I was mentioning earlier, where you first program, then bring the nodes online, and then you submit jobs to them. So, and you simplify that whole life cycle.
Sure.
Wish, for that, if we want to allow a user to give programming rights, we still need to have a bit of extension of API. Like the device plugin need to say which additional cups need to be provided to the container.
Is it possible for container to claim enough security capabilities and option in its spec?
Yeah, so that's what I was going to suggest as well. Like have an admission controller that looks at any resource that is of type FPGA or foobar, and then inject the right capabilities that it'll need during admission time rather than like during runtime. So I'm just saying that like there's enough Kubernetes extensions at this point where you can like actually build a workflow for this device and start adding value to users even before like extending the system.
Okay. There was some discussion in the document about scheduler extension versus admission controller. Why would you prefer admission controller or scheduler extension?
So the thing is, you cannot really modify the pod spec once it's admitted by the API server, except for like the object meta. And the assumption is that like all the security policies that an administrator has put in place are being evaluated as part of admission. So it's really not like, it's not the Kubernetes model to have some extension running later in the life cycle of a pod to go and like elevate privileges or like change the pod spec. So that's not what the extensions were actually designed for.
Okay.
A question. So is it possible just for containers to specify enough security settings in its spec?
I'm saying that if they really want to like improve the user experience, they could do it automatically via admission control. But as you're saying, like to start with, as like the that simple solution, you can just have the container request the right kind of capabilities.
Yeah,
so
it's just like to start with something really simple. We can just have container to require enough security settings.
Right, that's fine.
Yeah, and just you'll be able to do that as well, Vish, with a mutating webhook in 1.8, right? So
right, exactly.
Or I'm sorry, 1.9.
Yeah, assuming it'll go beta then.
Just to go back to one of the previous points, if you look at today's APIs, the actual code, it takes a pod spec. The schedule one takes a pod spec pointer. So if it were to modify it, it'll actually get reflected back in the main scheduler. So without any changes to the scheduler extension APIs, it looks like we can actually modify the pod spec. I understand it's not what it's meant for, but without any further change, it seems to work, right?
So the thing is, you cannot modify the pod spec during scheduling phase because the scheduler looks at a pod spec after the pod has been admitted by the API server. And updates to the pod spec are disallowed except for like the image name or annotations. So what we are suggesting you do is like, as Derek was saying, maybe a webhook is a better model where like maybe you have an extender, but the extender is also acting as a webhook. And what it does is like, whenever it sees a pod that requests a resource that your extender is supporting, then it injects the right capabilities or any other security privileges that you need for the pod, right? And then it goes through the regular admission process, and an operator can enforce whatever pod security policies that they want to. And so there's no like elevation of privileges happening in the system.
Okay.
Yeah, I mean, I, if I were you, I'd probably do that simple thing that Chang was saying, and that like not even deal with security in an automated way, just have the container request the right capabilities.
Sure, right. Okay.
Renaud, if you're asking if we can hear you, no, we cannot hear you.
So I think after the initial model and after you gather some user feedback, would be great if you can come back and maybe have another document describing the further needs, and maybe at that time we can discuss how we can support the more advanced use case better. But we hope we can have enough data to show the importance to support those use cases.
Okay. Sure.
Especially for the document, it's very helpful.
Oh, thank you. Sure. Yeah.
So on this particular topic, any other items you want to close on? Otherwise,
one question. In the document, we also mentioned we think about missing the deallocate call. So what was the story about it in previous proposals? Oh, like in the initial device plugin implementation.
Which?
I'm sorry, I think I missed the last part of the question. Oh.
So what was the idea in initial device plugin implementation? What we don't have right now, deallocate API.
Yeah, there was no use case for it. And like what we said was like most of the deallocation stuff that one would want to do, they can do it as part of allocations.
Yeah, and also mostly to make things simple because I think in Kubernetes, we are trying to be stateless. So to be able to reconstruct the state from the current state, the running state. So just to make things simple.
But the plugin may want to track the resources internally, right? Even if it's not exposed to the APIs, it may internally track the resources and the device it's managing.
Right, but if device plugin want to track that information, say if the device plugin dies and restarts, it will need some way to rebuild that information, right?
Yes, that's the job of the plugin itself. Let it do whatever it wants.
So our original working assumption was that plugins would be stateless and like they would have little logic as much as possible. And like most of the logic would be any logic that can be abstracted and centralized would probably be in the kubelet. But I mean, like, our assumption was that anything you can do with deallocate, you can sort of do it during allocation phase. If that is not true, and if you have like a really concrete use case for deallocate, then like just please bring that up and we can discuss that, I guess.
Well, a simple use
Can you hear
case
me?
can be just like shut down the power on specific device, especially if it's something external. Well, fine.
Right, but currently even on kubelet side, we don't have a good way to know when the allocation actually happens. We kind of do that later during like the next time of allocation. Just look at the active part and reclaim any resources not used by active part. So just on kubelet side, we don't really have a good way to know when the allocation actually happens.
Well, I mean, I don't know if that's entirely true in the sense that like kubelet is the entity that's deleting the pod object mostly.
Yeah.
And so
But
kubelet
currently
owns the
we-
life cycle.
Yes, but currently we don't have that.
I think in the device plugin manager inside kubelet, I've seen where there is a function which does the deallocate. It just didn't call the same deallocate method in the plugin.
Yeah, I mean, so in theory it's possible. Like Yang is saying, it may be a little bit involved and it's not like very straightforward. But the thing is, we didn't add it because there wasn't a clear use case. You can come up with clear use cases, sure. But even in the case of FPGAs, like what I've heard so far is like the device may be shared, so I don't really see how we're going to like shut down the device. So I'll probably like wait for.
You can shut down parts of the devices, and same for GPUs. When you deallocate, when a pod is no longer using a GPU, you may want to do some power management on your GPU. Once your pod is done with the current GPU.
So can you hear me?
Yes.
Yes, we can hear you.
Great. So just for the deallocation part for GPUs, it's not that we didn't have a clear use case. We do want to wipe the memory. We do want to be able to do a few things on deallocation. We just moved that part to the allocation part because it was more reliable. And it might be interesting to shut down the GPUs, but that's not usually what our customers do.
Yeah, I mean, we've never heard of this before. I'm totally with everyone here that like this may be a valid use case. It's just that like we haven't had customers ask for it yet. So it just may be that like we need it in the future and we just don't have a concrete enough use case for it.
Yeah, I think if we have a strong use case to support this, we can edit that. It's just like in the initial prototype, we want to start with something simple. So we kind of push the reclaim of resource at the next allocation time.
So I do want to come back on two quick things that I've heard, but I couldn't talk. The first one is I remember Vish mentioning, I don't remember who mentioned it, but the scheduler extender. I've been through that part during the initial implementation of the device plugin for GPUs. And there's a lot of not really straightforward issues that you're going to encounter. So for example, if you have to inject things in the pod spec in the scheduler extender, you end up having to delete the pod and recreate it. And the scheduler extender is not the best place. You probably want to do it at the admission control level. And the other one I was looking at, I remember is, so I heard you mention that you wanted to inject the security context. And I didn't understand, at least I think Vish was the one who was pushing back on this. I didn't understand why the device plugin can't do that. Because it feels like exactly what we would want to be able to do at the device plugin interface. Right?
Yeah, I mean, it might logically make sense, but practically speaking, as a cluster administrator, I don't want my pods to have elevated privileges. Like I would want to like know that either it's a dedicated node, at which point like I'm not really applying any sort of pod security policies, at which point I don't really care what the security policies are on that node, or it should be like a centralized policy, and policies are enforced currently at the cluster level, not at the node level. And so I would prefer like not injecting additional security privileges during the rest of the system, like even if it could be at the scheduler level.
Right, but device plugins are supposed, or at least we expect device plugins to be deployed by an administrator, cluster administrator. And I mean, I'm not exactly sure if security context is needed, but if it is needed for you to program your device plugin or your FPGA, then it would make sense, at least for the cluster admin, to say, oh, if these, for example, this group of users wants to be able to program the FPGA, then I understand that they need more privilege for their containers. Then it would make sense, right?
In any case, I'm just suggesting that we should do it at the cluster level, because Kubernetes security policy enforcement is happening as part of our mission, and we should just stick to that.
Yeah, I think Vish's point is it shouldn't be in the scope of device plugin.
Correct.
Okay, thanks.
So you're assuming that the user will know exactly what kind of security and permission and capabilities he knows about the specific FPGA hardware and drivers and kernel interfaces.
To begin with, that could be a working assumption, or like we said a few times, like you can have a webhook or an initializer or whatever you want to use to like do this as part of admission rather than after admission. So you would do it before the pod spec is accepted by the API server.
But the device plugin has an intimate knowledge of the kernel interface that are going to be needed for programming a specific device. The API server does not have this knowledge.
Correct, and the model that Kubernetes has chosen is to like enforce security at cluster admission time. So given that that's the model that the project has chosen so far, we cannot like really change that now just for this use case. So
I'm not looking at FPGA in particular, but I think it's a generic use case where you need specific permissions for programming a device. And then, so what you're saying is that the Kubernetes architecture is saying that this should be a priori knowledge.
Correct, and you can alleviate user pain by having add-ons at the cluster level, which work closely with device plugins. That will then like elevate privileges appropriately in order to make this happen.
And also, I think if we want to support the container programming model, it seems reasonable to expect the containers to know what kind of privilege it need to require when it want to program FPGA device.
Yeah, I mean, like this is pushing like doing things in the extender or doing things in the device plugin is sort of pushing us towards an imperative design, which is exactly what Kubernetes is avoiding. So I would say like just start with the thing that's possible today, and then we can explore further if necessary in the future.
But he does raise a good point in that at admission you don't know where your pod is going to land, right? So how would you know what security context you need?
Well, I mean, you know what devices your pod is going to consume, and you could presumably create a cluster level understanding of like what are the security privileges necessary in order to access a device foobar, and then just apply that.
Right, but if I take, for example, the example of GPUs because it's easier for me, you know you want a GPU, but you don't know if you're going to have a very old GPU, for example, a Kepler GPU, or a very new GPU, for example, a Volta GPU. And if for example, still in NVIDIA, it's not the case. It's not the case at all. But if I take the potential example that you're not going to do the same thing for a very old GPU than for a very new GPU, then you still have this problem that you don't know what GPU you're going to have at admission time.
Sure, and that's the problem of like having more expressible APIs, right? Like I don't want to conflate one problem with something else.
Yeah, if the old GPU and the new GPU different enough, they probably also require different CUDA versions and those things that containers do need to care about, I think.
Yeah, let's start with something very, very simple, and then we can think of extending. Like adding mutating the pod spec in any way after admission is sort of pushing Kubernetes towards an imperative model, which I think will face a lot of resistance from across a lot of people. So I just feel like it's not worth a conversation at this point unless we have exhausted other options and we have a concrete proposal for why we have to change that model.
Okay, that makes sense. Thank you.
Okay, so are we ready to, do we want to discuss topic 2 for today, or now that we can hear you?
Sure. Let me just share my screen. Can you all see the design document?
Yes.
So I hope now that everyone has taken a look at it. I wanted, I think I wanted it to, I wanted to come back on basically on the goals. So in my mind, I've actually completed the list of different bugs and shortcomings and fixed bugs. And so as I was completing this list, what one of the goal, or at least the main goal of this design document that I try to address is that the number of bugs that we've had, the number of shortcomings, the code coverage, the painful test system, I mean, the flags and lacks of performances, that's pretty much for me, that's a signal that says the current architecture that we have is just not good enough. And if we're going to continue and adding features, or if we're going to continue adding features, then I mean, this architecture is just going to continue and surface more bugs. That's my feeling from looking at all the number of bugs that we've had, because for one feature, the number of bugs that we've had is pretty much astonishing. And so that's the goal I'm trying to solve here, and that I want to. Okay, go ahead, Jane.
Sorry, but I want to point out, I think some bugs listed here, kind of like an integration problem. Like for example, device plugin handles allocation of resources it doesn't manage it. It's kind of like the integration with the resource name API, and like for example, the E2E node test is flaky. I think I don't think it's flaky right now. I think it was flaky mostly at the beginning when the node test itself has some issues. I just want to.
Which is why it's a fixed bug, right? So what I'm trying to point out here is that we've had a lot of bugs. We fixed them, but we've had a lot of bugs, and I think it's mostly due to the architecture rather than. Or at least I think it's mostly due to the architecture.
I think that's why there's some disagreement, Renaud, in that like it's beyond just the kubelet side implementation. There's like a really early device plugin implementation that we are using for end-to-end tests, and then we are relying on like GC infrastructure, and we are relying on our driver installation mechanisms and so on. So there's like a lot more variables than just the device plugin architecture. So it might be a little bit premature to like say that it's a device plugin architecture that's the cause for all bugs. I think that's what Zhang is trying to point out by giving concrete examples.
Yeah.
Right. So this is also a second. I understand that, but I was also thinking that if we're going to continue adding more and more features, or at least if we're going to continue on adding more features, then it would be good to have a reliable test infrastructure that is not flaky, that does not take 60 seconds, and that we can actually pretty quickly send. I mean, I've looked at the test and I've written a lot of tests, and what I feel from the PRs that I've seen and from the code I've written is that writing tests currently is very painful because we've got a lot of setup, we've got a lot of tear down to write, and that at least is in a big part due to the architecture, and that's why I'm trying to change it.
Right. So you're saying you're looking at it in one way. I mean, possibly like internal unit tests could be simplified a little bit by having a more modular and object-oriented model. But there's also the overall like functional integration tests, and we wanted to improve that as well. And there's some work already going on for that, which a few of you are like shepherding, which is about like having stub plugins which you can run in like both a node and a cluster level setting, and then you can then like do soak and scale testing, and you can try to reproduce real world scenarios. I mean, having really good unit test coverage is very, very helpful. I'm like all excited about that, and the fact that you care about it is very helpful. But I think we should also like think in terms of how can we better spend our energy? Like if we spend all our energy on improving just unit tests, would that be enough? Or would we have to spend our energy on the class level tests too? So I think it's worth looking at it from an overall system problem, and then like prioritizing where we have to spend our time, and then going ahead and like solving the problem.
So I think there's multiple things here. At least from my point of view, a lot of the tests that we have are at least at what was the CM package. A lot of these tests are more integration tests than unit tests, and so we could probably move those tests. But the point is mostly that I'm sorry, I just lost the track of what I was trying to develop. So the point was mostly that if we're able to at least get a few tests here, or at least the integration test should not conflict with the unit test effort. And if we're going to go on down the road with saying that our main point for this milestone is to have stability, then integration tests and unit tests should be objectives, right?
So maybe we can move to your proposed architecture change. I think I think which point is improving unit test performance shouldn't be the solely goal, the sole goal for the architecture, but maybe we can look at your proposal. I think you made some good observations, the current architecture has some limitations, and maybe we can simplify it by looking at how we may simplify the locking logic of the current code. I think it's a good point, and I think I commented in the document that maybe in 1.9 we can see whether we can merge the manager, device plugin manager and device plugin handler interfaces into a single public interface. Since now the code is in one directory, and then we can have an extra component to store the cached information for device plugin that can simplify the locking logic.
Yeah, even before we get into this conversation, I just want to make sure that everyone else in the call, possibly including me, I'm a little doubtful if we are all aware of the nitty-gritty details of the internal architecture. So would it make sense for this discussion to happen between the folks who are very much familiar with architecture rather than in this setting?
I'm fine with that. Yeah.
We can totally continue discussing, but I'm just not sure whether it's worth everyone's time on this.
Sure. Yeah.
Yeah. So Nicholas, like to subscribe to this. I remember we did some meetings very early on where there was the device plugin being discussed exclusively, do we need to do that again and have another track where we talk about the refactor needed?
Yeah, I think it might make sense. Like there might be a few people trying to work on this together, and so whatever means is helpful to facilitate collaboration and communication, I think we should just do that, whether it's a meeting or a Slack or a mailing list or whatever.
Yeah, or like issues or like a document or
Right.
whatever. Yeah.
Right. I mean, keep it in the public as much as possible so that other people can also participate. But I feel like this is really specialized discussion there, and it's also a little bit subjective because how one writes code might be different from how someone else writes code. So
Yeah, that's true.
like all I'm saying is like just spend your energy wisely and like solve the problems that are currently burning and then move on to the rest.
Renaud, can you?
Yeah, go ahead.
Renaud, do you think you could arrange like some kind of poll in the working group Slack where we figure out how to go meet and talk about this?
Sure, that sounds good. I think I'll just do that after the meeting, and which I mean, if we decide to go through another, then I think this is the end of the meeting.
Okay. Do we have any other topics?
I think that was it for today's agenda. Thanks for folks who were joining. And if there's nothing else that people want to discuss today, we can adjourn 10 minutes away.
I just wanted to plug, so Harry Zhang, Resour on GitHub, and Balaji and I are putting together a topic proposal for KubeCon, the Contributor Summit, to discuss intra-node topology enhancement. So stuff like making the CPU manager and the device plugin manager coherent in terms of NUMA affinity for decisions. So just a heads up that we'll be submitting that as a topic, and hopefully it gets accepted. And if so, I'm looking forward to discussing it with everybody.
Okay. Well, my gut feeling is that we would not really be having enough time to actually go over that. I think the meeting that we had in May, where we actually had a couple of days to discuss this with the whiteboard, it's probably a better setting for it. But in any case, like we can give it a shot and see if we can make some progress.
Okay. Well, that's an interesting point too. Is do we want to have a round 2 of the face-to-face that we had last year? I think that was super productive.
Yeah, I would prefer we do that than try to make people feel that anything that's happening around the KubeCon event is like a decision-making event. It's not supposed to be that.
Yeah, and I would expect a lot of people to participate because all meetings are expected to be public except for the Dev Summit. So it's...
And even the Dev Summit is not a decision-making event.
Yeah. Right.
And I think some folks will dial in, like within. Probably not everyone will be able to go to the KubeCon.
Yeah, I think maybe a different way to state what Derek and Jang are saying is that like we have to make sure that most of the decision-making folks are available when we are actually doing that. If we actually want to like make progress.
Yeah. So I would be interested in if we had enough subjects to discuss, potentially doing another in-person meetup as an extended group. We just need to get that scheduled and figure out if we could get a host.
Yeah, should probably do it like 3 months out, and so if someone can like start collecting topics and create an agenda, then that might be a good start.
I'd like to make sure if. Go ahead.
Oh, I was just to wrap up. So you guys are saying that maybe that's not the right forum for that topic.
Well, I say that for 2 reasons. One, I won't be there, and so I don't want that to be the decision-making forum. And then 2, like when invites went out for this, it's intended to be more like a place just for people to discuss things, but not decide things. So as long as we understand that we're not coming out of these things with decisions, then people can discuss what they want to discuss, but I'd prefer that we have a more dedicated topic or discussion for it.
Okay, that makes sense.
Yeah, my gut feeling
Just
don't really make much progress during KubeCon.
just quick question. Would it be possible to have a Google Hangouts for that? I won't be able to attend the KubeCon.
I hope so, because I won't be able to attend.
Yeah, that's like a shared problem, Renaud. So yeah, we'll have to figure that out. And I think that was even, there's even debate on who would be invited to things like the Developer Summit and trying to get that ironed out. And I actually don't know if the steering committee shared that yet, but like point being, like we shouldn't purpose the topics that we discuss here to be too focused on potentially trying to drive decisions where we can't get wide attendance.
Yeah, I completely agree with Derek. I think, like, I mean, if I had to just stay straight, then I think KubeCon is probably not the right setting for discussing technical discussions, especially in this area. If you're going to like attract more wider participation from the community, then KubeCon might be a good venue. But even then, like, you're not making decisions there.
Yeah, it makes a ton of sense. I agree. So, okay, we'll just.
But I'm excited, Connor, that you want to talk about the topic, because the topic is important to all of us. So, if you have materials,
yeah, we'll just
beforehand. We'll have to see them.
Well, it gives us more time to think, and we can queue it up for the next meeting that we have.
Okay. Well, thanks everyone. I gotta drop to do another discussion, but if you have topics for next week, add it to the agenda, preferably at least one day prior, and we'll sync up again. Thanks again.
Thanks for
Thank you.